Hello everyone and thank you for your attention. I am Moataz, PhD student from ETS Montreal, and I would like to present to you our recent work entitled Anti-Patterns in Modern Code Review Symptoms and Prevalence. Uh, code review is a widely adopted practice in open source and industrial projects, and it is necessary to maintain code quality, find defects, and ensure transfer knowledge. Initially, code review started as a manual, synchronous, and in-person process called code inspection. This process is done on a weekly or monthly manner, and it is known to be slow, not agile, and not suitable for large teams and projects. Nowadays, code review migrated from code inspection to a lightweight, tool-supported, and asynchronous process called modern code review. We show in this slide the process of modern code review based on Gerrit code review tool. Essentially, this process starts by another uploading a code change to Gerrit. Then Gerrit invites reviewers to review this change, and once the reviewers accept the change, they start exchanging comments and messages with the author to improve this change, and if the change is accepted, it is merged in the main code repository. An example of Gerrit code change screen is shown in this slide, and it can provide us with a lot of data like the change ID, the author name, the list of reviewers, the list of votes, the description of the patch, the list of modified files, and the exchanged messages. So despite being effective, not following code review best practices can lead to several problems and can have several effects on the quality of the code. To illustrate the severity of modern code review problems, we show an example of code review extracted from OpenStack, suffering from multiple problems. We can see that this code review suffers from low review participation since the patch was uploaded on the 11th of May, and the first reviewer's comment was on the 29th of May, taking 18 days idle. Moreover, we can see that the reviewer MCRA is not clear about the rationale of the patch and asking for the reasons of it. Additionally, we observe from the reviewer score and the discussions that there are divergent review scores in which the reviewer J. Bryant and provided +2, whereas the reviewer Sin MCRA is provided -1, blocking the merging of the patch. Clearly, all these problems resulted into heated discussions between reviewers and the patch author and lead to abandoning the patch, as shown in the last comment of the author. And hence, from the example, we observe the importance of providing, detecting these problems in an early state of the code review. Several studies reported problems in modern code review. Hyro and AI studied divergent review scores in OpenStack and Qt and showed that between 15% and 37% of patches receive divergent code reviews. Also, confusion review code review have been studied by Albert and Eyal, and they found that it can lead to slow integration and degradation in the review quality. McIntosh and Eyal showed that review coverage and participation impacts the number of post-release defects. Finally, Yoshua and Eyal showed that reviewers with long discussions and high disagreement lead to design degradation. So, despite the maturity of MCR-related studies, there are several problems remains open in modern code review research. For instance, despite their importance, there is no unified framework for modern code review problems like other anti-patterns for other disciplines like CI, code smells, and service-oriented architectures. Also, there is no study attempted to quantify the frequency and the prevalence of these problems. In addition to that, detecting these problems remains an open challenge since there is no conscious about how to detect modern code review problems. And finally, our research comes as an attempt to fill this gap, and we managed to do that by providing a catalog of anti-patterns called MCRA and its associated symptoms, and then we study the frequency and the prevalence of these anti-patterns. To achieve this, we start by analyzing the state-of-art papers, and we extract a list of anti-patterns and their symptoms. We label MCR data based on the symptoms defined earlier. Finally, we perform some analysis to extract insights regarding anti-patterns, frequencies, and prevalence. In the end of the process, we identified 5 MCR anti-patterns, and in the coming slide, we discuss the anti-patterns, catalog their symptoms, and the results of RQ1 and RQ2. So to investigate the frequency of each anti-pattern in practice, we considered OpenStack project that adopts a review process based on Git review system. We randomly select a sample of 100 code review samples to be manually inspected to identify the possible existence of anti-patterns, and the random sample covers across all repositories and covered reviews from November 2011 to July 2019. So we divided ourselves into two groups, each of 3 persons. The first group labeled CR and DR, while the other group labeled LRP, TR, and SR. We conducted first an open discussion on 10 data items to agree on the classification, and finally we label all the rest of the data and calculate the agreement metrics. So as we said earlier, we defined 5 MCR anti-patterns, and the first one is called confused reviewers, and it can be defined as when the reviewers cannot understand the reasons and the concept related to the change. And it can be detected if the reviewers raise many questions regarding the rationale of the patch, or if the reviewers' comments contains a lot of uncertainty expressions. For the second anti-patterns, it is called divergent reviews, and it can be defined if the reviewers cannot agree on the final evaluation of the patch. And these anti-patterns can be detected if the reviewers make conflicting votes, or if the reviewers' decision do not reach conscious, or if the number of the exchanged messages is high. The third anti-pattern is called low review participation, and it is defined when the reviewers are not involved in the process and provide slow feedback. And it can be detected either when the number of reviewers is low, or the code change receive fewer short comments, or the reviewer's reaction to the owner's revisions is slow. The fourth anti-pattern is called shallow review, and it is defined when the reviewer does not provide insightful comments to help author improve the change on the functional side. So, and it can be detected if the code change receive a high number of nitpicking comments despite its complexity, and if we have a complex patch but there are no inline comments addressing the details of the modified files. And finally, the last anti-pattern is named toxic reviews, and is associated with the presence of toxic interactions between developers and reviewers in a given code review, and can be simply detected if the patch have no controversial discussions, not related to criticizing the code, or the code review comments contain negative sentiments, harsh and rage expressions, and an unusual uses of emojis and punctuation side. Regarding the frequency of MCR anti-patterns, we summarize the results of the frequency of all of these anti-patterns in this table, and we found that LRP is the highest, is the anti-patterns with the highest frequency, whereas TR is the anti-patterns with the least frequency. We also have a perfect agreement for 3 out of 5 anti-patterns, and the agreement for SR and TR is substantial, and this is explained since detecting them requires a degree of subjectivity. Regarding the prevalence of these anti-patterns, we summarize the results in the following table, and we found that 67 of the MCR instances have at least 1 anti-pattern, while 21% of them have at least 2 anti-patterns, which show that anti-patterns really exist in our projects. In summary, we provided an MCR anti-patterns catalog named MCRA, and it is extracted from literature. We presented a preliminary study on the frequency and prevalence of these anti-patterns in OpenStack, and as a future work, we plan to validate our proposed anti-patterns and their symptoms. We also plan to extend MCRA with more anti-patterns and symptoms. We also plan to study more open source and industrial projects and propose methods to detect these anti-patterns. And with that, I would like to thank you all for your attention, and I'm looking forward for your questions.